In this video we're going to talk about linear equations and contrast these with higher powered equations such as quadratics and cubics. But we also want to show how to solve these equations. Now this overlaps with material in some other videos that we supply. We don't make any apologies for this. This is just reinforcement. It helps you to make sure that you're clear about the processes and how to solve simple linear equations. But to start, we want to talk about why linear equations. And let's get into looking at some examples. A linear equation is not raised to a power. So for example, y equals 2x plus 3. There's no squared term or cubic term here. There's no higher power. There's an implicit power of 1, 2x to the power of 1. That's just 2x. But there's no 2x squared. There's no little 2 up here, or 3 or 4 or whatever. So we say this is a linear equation. So we don't have the x squares or the x cubes or the x to the 4. It's an x to the 1. We don't write it, but implicitly there is a 1 in there, so we say it's 2x, and this is what we call a linear equation. There's none of these 2's or 3's or whatever. There's no other powers here. There's nothing written here. So just to drive that, drive it home, it's y equals 2x to the power of 1, which we don't write. We don't write the 1 plus 3. Well, that's the same as the one we've got above. Now let's look at a column of numbers. We're going to use a spreadsheet. Well, rather you can use the spreadsheet. This works on Google Sheets or on Excel or whatever spreadsheet you're using. All of them can do this just about. Well, I think all of them can do it. So here we've got a column of numbers, and I've just really marked one of the cells as x, and then I put in a -10, -9, and I copied it all the way down 9, 8, 7, 0, and then it goes 1, 2, 3, 4. So it turns from negative here into positive. That's all. It's just a string of a column of numbers. So nothing sophisticated about it. Do it on a spreadsheet and you'll end up with something like that. If you do 2x, well, you just take the first term here and multiply it by 2, so you do a 2 asterisk and you take the cell reference here, whatever the cell reference is, and write it in there. So it's equal to 2 asterisk cell reference, this one. So you write that in there, and when you click return you'll find it's -20. And you can drag that down and go down to the bottom. So it's negative numbers all the way down. We've got the zeros the same, but the 20 is at the bottom. So the zeros are the same, and it's 10 and 20 at the bottom, -10, -20 at the top. So now we've got 2x. So we're on our way here. We've got y equals 2x. We've got x and we've got 2x. We haven't got y yet. So we need a column of 3's there. So we put in 3 for everything all the way down. Now we got y. Y is equal to 2x plus 3. Now if you look here, 2x is -20 and we got a 3. So -20 plus 3 is -17. -18 plus 3 is -15. -16 plus 3 is -13. So we've now got a column for y. We've also got a column for x over here. So what we could do now is go to our spreadsheet and go to the graphing section on our spreadsheet, or the charts section on our spreadsheet, depending on what it's called, and click on it. It's a simple linear equation, and you find when you graph it, it looks something like that. Depending on which graph you've pressed on, but normally you can get a linear one like this, which is very popular. It should be on the ribbon at the top of the the spreadsheet. And you can see here it's just a straight line. And that's why we call it linear. It's a linear equation. It's a line. In fact, it's a straight line. So it's a linear equation. Since we're here, let's just play with this one for a moment. Let's say we had y equals 2x squared plus 3. Well, now we've got a column of x and a column of y. In this case, y equals 2x squared. That's how you write 2x squared in spreadsheet language, plus 3. So here we have, if you do that, we will get this figure here. So it's x squared minus 10, which is 100, plus 100, twice that, so it's 200, and plus 3 is 203. And we do that for each one. So now if we graph y against x, like we've got there, we'll get a set of dots like this. And this is a parabola. That's the technical name. That's a quadratic. So it's a squared term. And we won't be solving that for a bit, not for a while yet. But just to show, that is not a linear equation. It is a line, but it's not what we mean by a linear equation. A linear equation to us is a straight line. But since we're here, we can just illustrate these. If you wanted to do cube, you could do the same thing. Exactly the same. Set up a column for x, minus 10 all the way up to 10, let's say. And in here, just enter the formula. So it's minus 10 plus minus 10 times minus 10 times minus 10, which is the cubed, which is minus 1,000. Multiply that by, multiply it by 2, so it's minus 2,000, and add 3, so it comes minus 1,997. So that's how we get that figure. And if you graph it, you'll see it's again a curve. It's not a straight line, so it's not a linear equation. And that's a cubic equation. That's what it looks like. And there can be all sorts. It depends on the figures we put in here. But once we've got a cubic term, typically it'll follow that shape. Now, we've established that y equals 2x plus 3 is a straight line. In the equation, we say that x is the independent variable and y is the dependent variable. This is actually important. Y, the value of y depends on x. Whatever the value of x, that determines y. But x does not depend on y. It's y depending on x. Y depends on the x. X is not depending on y. So x is independent. We call it the independent variable. And you'll hear this expression quite often as you go through your studies. A certain variable is the independent variable and a certain variable is the dependent variable. This depends on that. It's not the other way around. X does not depend on y. Y depends on x. The value of y depends on the value of x. Of x, not if x. Of x. So for example, 2x equals 6. To solve this is easy. We need to get rid of, we need to get the x on its own. So we divide 2x by 2 to get x on its own. So 2x divided by 2 is equal to x. But we need to remember to do the right hand side as well. So if we divide the equation by 2, we get x equals 3, because we divide the right hand side by 2. So we divide the left hand side by 2, we get x on its own. So x equals, what does it equal? Well, it equals 6 divided by 2. 6 divided by 2 is 3. The rule is whatever we do to one side of an equation, we must do to the other side also. Always remember, whatever you do to one side of an equation, do the same to the other side of the equation, exactly the same. Here we have 2x plus 2 equals 6. We need to get x on its own. So first of all, we get rid of the 2. Get rid of this 2 here. So we subtract it. Subtract it here and it's gone. Because plus 2 minus 2 cancel out. It's equal to 0. So get rid of it off here. Add in minus 2. But if you add minus 2 to the left hand side, you must add minus 2 to the right hand side. So we add minus 2 here, we add minus 2 over there. The 2 and the minus 2 will cancel. The 6 and the minus 2 become a 4. So the 2 and the minus 2 cancel, so you have 2x equals 4. Now we need x on its own, so divide the left hand side by 2. If you divide it by 2, you'll just get 1x. Or in other words, you get x. So divide 2x by 2, you get x. Divide the 4 by 2, and you get 2. And that just gives us x equals 2. So we know how to solve linear equations, simple linear equations. Take a third example, just to be on the safe side. 3x minus 7 equals 12. Get rid of the minus 7 by adding 7 to both sides. So now we have 3x minus 7, like we have here, 3x minus 7 plus 7. Well, the minus 7 and the plus 7 are going to cancel out. That's 0. So that'll just leave us with the 3x on the left hand side. But we must add the 7 over here as well. So it's 12 plus 7. So we have 3x equals 19. And we need x on its own, so we now divide 3x by 3, which will give us 1x. 3 divided by 3 is 1. So 3x divided by 3 is just x, and we divide 19 by 3 to keep the balance. And when we do, we find it is a recurring decimal, 6.333333, and so on. And that's the value of x that solves the equation. If we have a single equation and a single variable, then we can solve the equation. So if we have a single equation and a single variable, we can solve it. So 3x minus 7 equals 12, we can solve that. X equals 6.3333, and so on. And that's all we really need to do with single linear equations, simple linear equations. So let's leave it at that and say thank you for watching.